Hello again, my friends. So, welcome in 2025, a new year, a prosper one, I hope, for everybody. And let's talk about some audio stuffs today, recording and this kind of topic. I'm using my portable recorders on the stage, recording live gigs, and that's why I bought me a Tascam DR05 to back up my old Attenuator R09. This machine is very capable, really good microphones, really nice sound, but I'm intending to use it mostly for recording. Like a stage mixer, I'm using a Yamaha Stage Pass 1K Mark I, and the signal is coming from monitor output. The point is, when I hooked this one to that particular signal output, I found that the signal is too hot, the level of the signal is too high for this guy. I didn't realize, but as you can see here, doesn't have a dedicated line in input like Attenuator have. The point is, I can still use it, but we have to do a kind of adapter. And by the way, let's take a look at the technical stuffs, and there we go. So the nominal input level should be minus 20 dB, so this is a perfect signal for this guy. The maximum input level minus 4 dB, well, it's still a very sensible input, and the impedance is 25 kilo ohms. All right, very clear. Somehow we have to bring that output signal from my stage monitor down to minus 20 dB. I did some measurings and some experiments before a gig. Let's see. Here we go. So you see, that's the signal path getting into Tascam. Even with the level down to 0, the signal is still hot and it's peaking all around, you see there. Okay, I can't do anything about, because that signal is going also to the ambient loudspeaker system in the restaurant. And here I use my Fluke to measure the output, which is passing easily 16 dB, even more than 20, and that makes the things running crazy. Okay, so here is again the Tascam. Look there, way too hot. Okay, what I'm trying to do today is to build a kind of attenuator and to bring these guys down to a proper level. And there are a lot of mathematics involved here. We can do a lot of mathematics, let's call it, to find about the values of the attenuator resistors, and that's why I'm gonna have a very simple L attenuator. So let's do this. That's the input going to one of the resistors, let's call it R1, and that's the output. And here we have another resistor going to the ground, so this will be R2. You see, we have this formula down here: V out equals V in times R2, R1 plus R2, and that in volts. What we need here, V out, normally 0 dB means 1 volt of signal. That's kind of standard, line output, it's 0 dB usually. You know why I call it line? Because it's a kind of standard from the old time, the old telephony lines, something like this. Anyway, so I'll consider R2 around 600 ohms, kind of standard impedance for the line in and outs. So in this case, we need to have 0.01 here. That means 1 times 600. There is the X, R1 plus R2, and that means volts. Yes, we can do that very simple. So let's say 600 divided If we have 1 kilo ohm here and 600 will be 106,000 ohms. And that will give us 0.375 volts output. No, I need more. Maybe 2 kilo ohms, and that will be 0.20. No, this is not enough either. Let's try with 4,000 something. It's not enough. 4,600. We are getting close. Maybe 5? 0.12. Okay, so I suppose anything or 5 kilo ohms, maybe 6 kilo ohms will do the job. The point is, you see, I want to have this recording level somehow in the middle to have enough room for going higher or going down here. Before that, let me redo the experiment from last night. So I have my Fluke here on dB meter, and I'm using exactly the same song, and let's measure the signal. Let's wait for the rhythm. Here we go. It's passing. Yes. Maybe it's too hot. But that was the level, jumping all around. So now, if I'm connecting this to my recorder and put it on record, you can easily see that it's peaking and it's still hot even on zero level. It's exactly the same situation. To make this thing a little bit easier, I'm gonna have a file, a signal, a generated signal of 1000 Hertz. So I'm gonna have a length of 600 seconds, that means 10 minutes, with a frequency of 1000 Hertz, 1 kilohertz, with a level of 0 dB, that is 1 volt. Then there we go. I'm saving this like a 44 stereo 1000 Hertz file. Import this into my player here. That's the one. You see, we can have a much steady signal and the idea of the levels. Well, in the meantime, I'm gonna prepare for the build itself. Okay, 680 ohms. Perfect. That should be absolutely perfect. So for now, I got the parts ready, and here I have an input and an output jack. Yeah, I think I can use this just for testing purposes. Yeah, the file is in. Let's do a test now. Let me run the 1000. Let's check the numbers. 25 dB. You see there? Okay. So maybe I should go down to 20 plus 20. So we got a 20 dB here, very clear 20 dB. If I'm inserting this into Tascam, you can see with level on 0, it's peaking already, so that's not good. The intent of this experiment is, after building this attenuator, we should have at least 0 dB or even more than this. Okay, that's a very simple schematic. Okay, always flux. Let's measure these parts first. 5 kilo ohms, that's in series, and 6. Okay, that will be in parallel with wires here. Okay, let's see which is which. Probably the black is the ground, and it is, and then the red it's the top tip here. Perfect. Now let me check this guy for the same story. This is the ground and red goes to red. This is R2 in the schematic. My tip needs a cleaning. Resistor. Again, let me check the resistor. You see, this is just an experiment. A proper case or enclosure or something, it will be done after 600, that's fine. And this goes to the hot wire 2, something like this, and the red. There we go. And in between these two guys, we're gonna have the 5 kilo ohms resistor. There we go. It's done. Okay. So now let's see about the levels. Running 1 kilohertz file, measuring the level 20 dB. Okay. Let me have this in, and let's measure the level at the output. Ground and tip. 1.36 dB. That's a pretty good attenuation. It's like 19 dB, but I want more. Let's see. Oh, look there. Level on Tascam shows me minus 22. Let me go higher. More. Let me play the same piece of music of song. Let's wait for proper rhythmic. Oh, much better. And I can push it to maximum, so we have a whole. Almost there. Let me change this 5 point something resistor with something higher. Maybe 8. But you know something, this is an experiment, so I don't really care about fixed values. Oh yeah, we can use this 6.8 kilo ohms instead of 5. Alright, let's see what's the difference. So if you remember, we had like 19 dB attenuation with the 5 kilo ohms. Now we have a 6.8 kilo ohms. Let's play the signal. dB. We have 20 over there. Let's plug in the signal into attenuator and let's measure minus 0.22. Yeah, so I reached the goal of minus 20 dB. And now let's see what's happening. Oh yeah. Perfect. Much better. Let's play the music. And I think I can go easily for 10 without doubts. 10 kilo ohms. I'm pretty sure 10 kilo ohms will give me like minus 22. Look there. Let me wait for the song to got the. I'm picking if I'm passing 40. So now I have an attenuation of approximately 20 dB, which I may say it's perfect. Okay, so input R1, out, this is R2 or R2, and I use 680 ohms for R2, which is a kind of standard, let's call it impedance, line impedance, and for R1 7 or 6.8 kilo ohms. and that gives approximately minus 20 dB. Simple? Yeah, I think it's simple. Now I have to make this in stereo for both channels to have a proper shielding and a proper mechanical, you know, kind of plastic or a tube or something. And I think the problem is solved. If you want more, you can simply play with R1. So probably you can go up to 10 kilo ohms, and that will give like minus 23 dB and something like this. Okay, so I think that's it for today. Like always, don't forget to subscribe to my channel, push the like button, I need that. Thanks to my sponsors, Radu G from Belgium and Vlad Kaya from Amphia Records, and Jack, of course, from States. What else? Like I said before, wish you a really beautiful 2025, and I hope I'll see you soon with some other projects. Until then, don't forget, have fun. See you, bye bye.